We're going electric on the morning show today with Matt Sellon, and it's all in honor of Ben Franklin's birthday. He turned, what, 300 this week?
300 yesterday.
Yesterday.
Right.
Wow.
And he was an amazing guy. I mean, not only was he one of the basically founders of the country, right, but he did experiments on electricity, and his papers and thoughts were followed up on by scientists in Europe and all over the world. So he was extremely well known for his experiments that he did sort of in the mid-1700s. And so he understood how lightning worked, and he understood that lightning rods might help you avoid being struck by lightning and things like that. So that's what I wanted to talk about a little today.
Well,
so he knew that there was charges and that there was two kinds, and he called them positive and negative, or plus and minus.
Sure.
And you know, was one of the first people to do that sort of thing. And you can have experience with this yourself at home by taking a balloon, okay? And if you just take a scarf, this is a plastic balloon or nylon or latex balloon, and this is just an acrylic scarf.
Okay.
Two different kinds of insulators. When you rub two insulators together, because one is better at hanging on to charge than the other, you'll charge up one of those things. And when you charge something up, what happens is that you can get it to stick to something. So this thing will now, of course,
maybe.
Okay, I already rubbed this one.
Yeah.
Okay. It's okay. So it just sort of sticks to the wall because that thing is now negative, and that sort of attracts the positive charges in the wall, and they stick together.
Okay.
So opposite charges attract. The same kind of charge will repel.
Sure.
Okay, and so that's how lightning works. And so what this device here has a belt in it that goes round and round.
What is this called?
This is called a Van de Graaff generator, and this rubber belt is an insulator. At the top there's some things that basically rub charge off this insulator. This thing gets charged up, this thing at the bottom does too, has the opposite charge on it, and you get sparks flying. And what I've done is I've attached a little wire from the bottom one to this bar, or this little ball up here, so you'll be able to see sparks flying when I turn it on. You can see this.
Do I need to stand back? Or?
No, it's okay. The belt spins, okay, and what you can see is that you get sparks at the top, okay?
And you said this is like the equivalent of rubbing your feet on carpet.
Right, except this thing is really good at doing this, and so what you're getting here, the voltage difference between the top and the bottom here is probably several million volts when we do that. Okay, but it doesn't provide...
You can't do this at home.
Well, you sort of can. It doesn't hurt you. You're going to touch this later, by the way. We're going to make your hair stand up. So what happens, what Ben Franklin realized was that these charges want to jump from the positive one to the negative one, or vice versa. And he also realized that it's very easy. It makes it easier for charges to jump if there's a place that's very sharp.
Okay.
So if I just take this little nail and I stick it over here, okay, so that now there's a sharp point sticking over on this side, I can turn this thing on, and you don't get sparks over here anymore. Because what happens now is that as this thing tries to charge up, the charges see that little point, they go there and they jump off, and they just hop down here in sort of a continuous stream.
Oh, wow.
Okay, so you don't see anything, you don't hear anything, because the sharp point is basically allowing this thing to discharge without a big stroke of lightning. A big stroke of lightning, wham, happens when you get a big voltage built up.
This so the equivalent of the lightning rod.
Right. And so this thing allows the charge to bleed off slowly before a big voltage builds up. So that's how lightning rods work. If you attach a sharp point to the ground someplace near your house, it sort of discharges all the charges that are stuck around there, and it helps discharge, basically helps it be less likely that the lightning is going to strike there.
Your house. Interesting. Yeah. Okay. And our balloon's still hanging out.
So our balloon's still hanging out. And so there's some pretty cool experiments that we can do to show that like sign charges repel, which we're going to do on your head when we come back.
You don't want to miss this. Physicist Matt Sellon, our wise guy today. If you have any questions for him, you can email us at themorningshow@wcia.com. 6:53 now. Robert, no lightning today, but a lot of static going on in the studio today.
That's true. Every time that thing popped, I could hear it in my earpiece clear up the other side of the building. Decatur Skycam.